Hi everyone, Ravi this side. Welcome to EnggAdda. Today in this video, we are going to discuss and solve one of the LeetCode array question, which is question number 674, and it says longest continuous increasing subsequence. So we have to find out the longest continuous increasing subsequence of an array. So that is what the question is. So let me try to go to that question directly and then try to read out and try to see what the question is and how we can develop the solution for it. So the question number 674, if we'll go down, you can see this is the question and it's in the easy section. So we are recently developing, or you can say solving, the easy question of the array from LeetCode. So you can see that this is the question, which is longest continuous increasing subsequence. Given an unsorted array of integers, nums, return the length of longest continuous increasing subsequence. That means subarray. So we have to return the length of the subarray, which is longest continuous increasing subsequence of that array. Okay. The subsequence must be strictly increasing. So let's say we have example is given here. Let's say we have the array has 1, 3, 5, 4 and 7. So you can see this array contains 5 elements, and if we'll start from 1, you can see that the next element, which is 3, is greater than 1. Again, the next element 5 is greater than 3, and if you'll go to the next element, which is 4, which is less than 5. So the continuous increasing subsequence is 1, 3, 5 and its length is 3. Now we have 4. And then if you'll go to the next element, which is 7, so you can see that 7 is greater than 4. That means we have two subarrays. One is 1, 3, 5 and the second one is 4, 7, which are in increasing order, and 1, 3, 5 is having the 3 elements and 4, 7 having the 2 elements. So the length of the first one would be 3 and the second one would be 2. So we have to return the longest continuous increasing subsequence length. So it should be 3 here. Okay, so the longest continuous increasing subsequence is 1, 3, 5 with the length 3. Even though we have 1, 3, 5, 7 is an increasing subsequence, it is not a continuous. So you can see that if we'll skip 4 here, we have 4 elements 1, 3, 5, 7, which is an increasing subsequence, but it is not the continuous one. So we have to find out the continuous increasing subsequence. Okay, so that is what the question is. So here you can see it is not a continuous, as element 5 and 7 are separated by the element 4. So this is one of the example. Now let me try to discuss about the second example, which is we have 5 2s. Okay, now the longest continuous increasing subsequence is only 2 with the length 1. Note that it must be strictly increasing. So you can see when we are looking for the subsequence, let's say we start comparing the next element with the first one, and we can see that it's not increasing. So we have the length, we can initialize our length with the 1 at least, and you can see we have a length as 1. And again, if you'll see the next one, which is not increasing, so the length would be 1 only. Again, if you'll go next and then see it is not increasing, the length would be 1 still, and the same thing happens till the end. So the length is 1 here and the subsequence is only 2. So this is what the question is, and how we can develop it out we are going to see. If you want to read out these things, like a continuous increasing subsequence is defined by 2 indices, L and R, where L is less than R, such that it is nums L and then nums L plus 1 is in increasing order till R, and then for each L less than equal to I is less than R. Okay, that means the number I is less than number I plus 1. So this is the condition that they have set, and this is what we discussed here as well in these 2 examples. Now let me try to write down the solution for it. So we already have discussed about the question, what it is, and we take out one conclusion at least, like let's say we have n number of elements inside the array. Okay, and that could be same, right? So we have to For that, the length of the increasing subsequence would be only 1. So I'm going to initialize the count, or you can say the length with minimum as 1, not 0. Okay, so we are just keeping in mind that the array would not be empty. Okay, so for that we are going to keep the minimum length as 1. So let me try to do one thing. Let's say I'm going to initialize a count variable which says the length equal to 1. And now what we have to do is we have to find out, let me try to put one condition here. Let's say if the length of, if we have array and that array is having only one element, in that case what would be its length of the longest common subsequence? It would be 1 only, right? So in that case what we can do is we can return the count. So let me try to write that condition first, and then we'll try to see. So it would be nums dot length double equal to 1. Then in that case return the count, or you can say 1 directly, you can return. But here I created this variable count, so I'm returning the count here. So that is the one condition we covered. And now let me try to put some other conditions, like we are going to iterate through the array, and let me try to create the for loop nums dot length and then I plus plus. So here what I'm going to do is I'm not going to start our array with the first element. I'm going to start our array with the second element, and they'll try to compare first with the second element. So that is why I'm putting the index of I as 1. Okay, so let me try to do that. So let's say if nums I minus 1 is less than nums I, then in that case we are going to increase the count. Okay, and let me try to also create one variable called max, which is having the minimum value. So integer dot min value. Okay, and we are going to, like, why we are creating this max integer is we are going to find out the maximum out of this max and count. So whichever is maximum, we are going to keep that in the max. So you will come to know when we are going to initialize and keep this max in place, then you will get why we are creating this out, and then how we can use it out. So don't worry on that. So for now, what we are doing is we are iterating through the loops, and then we are finding out the longest common subsequence, and based upon that we are increasing the count here. Okay, now let's say in that else condition what would be happening. Let's say let me try to keep this one as an example. So let's say for the first element we started with 3 and we compare 1. Now 3 is greater than 1, then we increase out the count. Now we have the 5 which is greater than 3, we increase out the count. Now we initialize the count with 1, and now with the 2 iteration the count becomes 3. Again for this third iteration, what is happening is nums I is not greater than nums I minus 1. Okay, so you can see we will compare this 5 and 4. 4 is not greater than 5. In that case we are going to this else condition, and where what we are going to do is we are going to find out math dot max of like max and count. Okay, so whichever is the maximum one, we are just keeping it with the max. And now we'll start from scratch, or you can say we'll start from the first element. So we'll keep this 4 as a first element, and then we'll try to find out the maximum, or you can say the longest continuous subsequence. So in that case we are going to initialize the count again to the 1, and we are good. If it is not happening, if we are not, like, let's say we have only 1 3 5, so in that case what we are going to do is we are just going to find out again this math.max of max and count. Okay, and then simply what we are going to do is return the max here. Okay, so this is what the code look like, and let me try to run this out and then see. And you can see it's working fine, I think. Let me try to increase the, so for these two cases it is satisfied. Now let me try to submit it out and then see. So you can see it's submitted successfully, and it took only 2 milliseconds and beats 34.59% of the solution. So it looked good. Now let me try to again explain you or summarize you the whole thing that we did here. So what we did is, if you'll go to the description of the question, what we did here is we take the first condition as, let's say if we have only one element inside the array, then in that case the length of the array would be 1, and that is the longest common subsequence we have, and we are returning the length of that as a 1, which is count here, and we initialize the count with 1. Now what we are doing is we are iterating through the array, and then we are finding out the continuous longest common subsequence. Okay, or you can say, sorry, continuous increasing subsequence. We are finding out the continuous increasing subsequence. We are not deciding here what is the longest one. For that we created this variable which is max. So here we are finding out the continuous increasing subsequence. Okay, and we are according to that we are just increasing the count. If something is breaking, then we are going to the else case and finding out the maximum till then. Okay, so till 135 we have the maximum length as 3, and that is what we are keeping into the max. Okay, and then we are initializing the count back to 1, and then we'll start from the 4 and 7 again, and that time the count would be 2, and here it will try to see the maximum of count and the max. So count will be having 2 and the max would be having 3. So max of 3 and 2 would be 3, and that is what we are returning here. So this is the code that we written down, and this is how you can solve it out. So this is about the video, guys. If you like the video, please hit the like button and please subscribe the channel for more such content. Thanks.